video is going to be a quick one about what pre-whitening is, specifically how it's used in NIRS and used in actually the NIRS Toolbox. So the whole idea is that we're dealing with time series data in NIRS and EEG and other things like that. And time series data is not a random selection of data points. It's not like I went to Joe Schmo, grabbed some data off him, went over to Sally, grabbed some data off her, went around the room and kept grabbing data through random people. Each data point that I grab is going to be related to the data point before it. So second 7 is related to second 6. It's also going to be related to the point after it. So second 7 is related to point 8, point 9, all that. So time series data is not unrelated from time point to time point, or in a sense, in fancy vocabulary terms, it is autocorrelated. The autocorrelation matrix just basically shows something like this. If you notice, the x-axis here is going to be time in frames, 0 to 5,000. The y-axis is actually inverted, so it's 5,000 to 0. So it's looking down, essentially, 0 to 5,000. The diagonal blue line is just basically showing that time point 0 is related to time point 0 100%. Time point 5,000 is 100% related to time point 5,000. And each coordinating point is 100% related to itself. The goal is that this line exists, but there is no other correlation off of this line. So any nearby points to the line are not correlated one bit. That's the goal. The reality is it's not quite true. We have something like this. So the blue line still exists. So in this case, it shows time point 400 is related to 400. Time point 2200 is related to time point 2200. However, it also shows that time point 399 is related to time point 400. Time point 398 is related to time point 400, and so forth. So what it's basically showing is that nearby points have some ounce of correlation to it. Another way to view it is through serial correlation. So basically, as you can see, the first graph here has a pattern to it. It follows a time course. The second one is seemingly unrelated. In the NIRS Toolbox, you're essentially dealing with similar things. So I have these a little bit backwards, but the bottom filter here is actually untouched. It's the natural correlation matrix, if you will. So what it's showing is time point 0 through time point 21. And time point 0 is going to be 100% correlated with itself. If I push time point 0 and compare it to time point 1, which is going to be, if you notice this lags x-axis, it's moving down, looking at time points more and more distant to the one of interest. It does decrease in value, but it doesn't decrease in value much. Also worth noting is the interesting pattern found here, which I can't really comment on other than that it's interesting. The goal, however, is to make it look like this top correlation matrix, where basically time point 0 is correlated 100% with itself, but 0% with any other lag or any other time point away from it. The filtered data, what it winds up looking like is something like this. So I have no filter going on, and you'll see there's kind of a variation across time with it. Once you have it filtered, it actually seems to flatten out a bit. Basically, I've removed this undulating curve within the data. To do that, you can easily just take a screenshot of this and use it. I won't go through too much through this, but to show the autocorrelation, I actually show it using this autocore function in MATLAB, and then I plot it in this second for loop at the bottom, showing the filtered data. So that actually gives you something like this, I believe this. The code itself in the toolbox, so the previous code was actually just to show it, to show the actual information, but to actually implement in the toolbox, you would run this code here. Basically, you take whatever pipeline you have. If you don't have a pipeline, you would, the J over here would be an empty value, but here we've implemented it, and we've saved the output as the J variable again. So you'll find it in the advanced folder, under the NIRS folder, under the modules, and the function itself is called AR PreWhitening. And here you would actually run the PreWhitening on the data. So j.run on the data, which is named raw. I saved it as an output variable called PreWhite, but you can save it as whatever you like. Anyway, I hope that was of help, and it gives you some rundown of that. I'll be posting up more videos in the future, a little bit more in depth, but I do hope that was helpful.